Okay, so I guess we're starting. Hello, everybody, and welcome to the Modular versus Monolithic scaling panel. So I'm glad you're all here. I hope you're going to have a good time talking, enjoying a little talk. I guess I'll introduce myself. My name is Pavle Batuta. I am a CTO at Moonstruck. I'm a blockchain developer, researcher. I've been in this crazy space for about 5 years and change. And I'm very passionate about this topic. I hope I'll be able to, convey it in the right way to you, and I'll pass it on to the rest of the guests and panelists. So, next to me.
Hi, I'm Max. I'm filling in for James, who's on the card from Superchain. I've been in crypto since about 2016. Worked on some fairly big infrastructure projects, building mining pools, validators, and specifically indexes, building lots of indexes for many companies. And this is our business now is Superchain, which is changing the way we do indexing, specifically around decentralization and speed. And we've been running Superchain for since December 21. So obviously won't talk about that too much today. James is talking on the other stage about us today, so I'll leave it for him. So.
Hi. My name is Marija Matic, and I've been in crypto since 10 years ago as a spectator, and the last 5 years or more I've been a crypto analyst. And I run, maybe locals know me since I run a BitBalkan channel on Telegram.
Okay, so maybe I can open up with a question, which is right out the gate. What does modular scaling mean to you?
I'll take this. So modular was first introduced through the Celestia or the Lazy Ledger white paper, talking about data availability as a means to scale the blockchain, so that instead of loading all of the data through the EVM and executing, is that you could have a data availability proof and then use the proof of that through the EVM as opposed to loading all the data through it. And then it came into the concept that you could actually separate the execution, the consensus, and the block building, and the data, sorry. And so that's ultimately the idea, is basically conceptualizing this. But when we look at Ethereum, we see that as the monolith, or maybe we find out that we did see it as the monolith, and that we could look at modularizing that as well, or seeing it as part of this modular stack that's being sort of conceptualized and developed at the moment. So.
When we talk about modular projects, Celestia consider themselves as pure modular project, and then we can call them modular first, and then we have Ethereum, which is monolith but trying to become modular, and many others, and also we have these modular first projects like maybe Cosmos, which maybe Celestians are not going to consider truly modular. So there are layers to these, and so it just depends on what are we talking to. But let's say that a modular is at least trying to offload or uncouple execution from consensus. So we have 4 blockchain functions, and these are consensus, data availability, execution, and settlement, sorry. So at least one of them, for example, execution, if you uncouple from consensus, maybe we can say, yeah, that's a modular. So now, I mean, if you want to talk if Ethereum has become modular, when it's going to become modular, is it going to offload all the execution one day to other networks, but yeah, I think now it's more a story about, not about monolith versus modular, but more about modular first and those who are trying to become modular.
Yeah, this is going to be a bit weird because I'm also answering my own question. But basically, I would agree with the panelists. Basically, you have this journey that started with monoliths, with this idea that you have one single universe of transaction, one single well-ordered transaction history. And this is a very good thing. And all these things, words are capitalized, by the way, because you can have amazing effects of interconnected and transactions that form one big unity. You have the ability to do flash loans. You have the ability to do very advanced DeFi. And it would be good to maintain this, this property inside a blockchain. However, it is very difficult to achieve this, and I think that modularization is a necessity across all projects. I think that what we have and what we're going to see is that most monolithic projects that are embracing this this approach are running into trouble. So yeah, I would agree that basically you have to have some kind of modularity in the stack if you want to scale, and this modularity is either implicit, where you have execution shards. You have like a blockchain that tries to have execution shards and then have implicit communication between these shards, or you have explicit modularization with like separate environments, and these separate environments are managed by different domains. They're managed even by different operators in case of rollups and so on and so forth. So basically, I don't think that monolithic scaling has it has a well-defined path ahead of itself, but it does preserve this this property, which basically allows you to have atomicity and locking transactions from different smart contracts and preserve this property, which is very, very beneficial. So I guess the next question becomes, speaking of rollups specifically, how do rollups fit into this modular scaling vision across Ethereum and across different blockchains?
Okay, so if we're looking at rollups, the need for rollups is we're looking at optimizing our gas costs. We're optimizing like the amount of transactions we can push through, let's say Ethereum, but do it. Let's say that the tokens that we wish, where the value is locked, is on Ethereum, and we want to then push that out to a layer 2 to run some execution where our application lives, and then write back the state, the new state, back to the chain. So this is the idea of the rollup. And then you have a couple of different types where instead of writing the state back, you can just write a proof back. So this is the idea of the validium. So this then produces, this can produce a lot of data, and this can basically be passed back into Ethereum, and Ethereum then has to process that again. So you're basically borrowing Ethereum for its security layer and settlement layer, and you're ultimately allowing your application to scale through many, many, many more transactions. So this is the original idea. Now it's been more conceptualized so that you can actually break up the different layers and build a completely independent blockchain. So it's not just execution and consensus off chain, like on a layer 2. You're now basically pulling that back into the Ethereum stack with the new improvements that we'll have in the upgrades coming. So specifically, we're looking at blob transactions to basically facilitate this. This was looking at how we shard Ethereum's data. How we can. This is this goes along the line of the proto-dank sharding, which is to come, which is the blob transaction. I think is the EIP 4844, which supports this. So that instead of executing, let's say, 10 megabytes of transactions through the EVM, you can execute those separately off-chain or on a layer 2, but then provide just a proof that that's happened and it can be processed on the EVM. So it's a very, very lightweight operation, but you've been able to process 10 megabytes worth of transactions, which in theory could get you up to 100,000 transactions per second. So that's like a really nice way to scale, and I think the innovation has really been pushed into the sort of modular blockchain stack as we're seeing Ethereum now catch up and look at adding in these proposals to basically meet the same expectation as such. So I think the idea from Ethereum's point of view is that these layer 2 solutions are more of a temporary scaling solution for now, and that Ethereum will catch up and be able to capture a lot of those TXs. So we'll have to see what happens with that. So.
Yeah, well, you said it all, Max. I'm not sure what I could add to that. Yeah, we're waiting for next upgrades, and What was unusual for me was there were some proposals that implicate that layer 1 users will subsidize for the cost of transactions for layer 2 users. I'm not sure what is going to be in the upgrade in the end, but we now have different topics to talk about, because if getting transactions cheaper for layer 2 users means getting transactions more expensive for layer 1 users, then where does it put layer 1 in terms of being used? As will the community, Ethereum community, decide in the end to maybe completely or somehow move the execution totally to other layers? So these are kind of interesting questions for me.
Well, to follow it up, if you have a situation where everything is on layer 2, you have a problem because you're now fragmenting the community. Essentially, different layer 2s have very different properties, and they are sort of mentally mapped into this same category, by which you're just saying, okay, instead of settling on layer 1, instead of settling on Ethereum or maybe some other chain, we are on layer 2s. And layer 2s are they can be very different. They have different properties. They have different levels of security, different levels of centralization, and this is can be a bad thing. The advantage is that, and I think this was a sort of I would even say a brilliant move by brilliant evolution strategy for Ethereum, is that to outsource all of this development across a very large number of teams, a very large number of projects that take different approaches and compete with each other. Now, as the problem with the increasing costs of layer 1 transaction might be that if you want to post proofs on layer 1, then this might become cheaper and cheaper and cheaper, first with proto-dank sharding, then with dank sharding, data availability shards. This can become a very cheap operation, and it might allow rollups to post more frequently, to have more storage specifically available for that purpose. But the downside and potential danger is, if we observe, and of course that's going to be my next question, what is even an L2 for you? It rhymes. The situation becomes like, if I want to bypass the rollup, if I want to post the proof, for example, a validity proof, instead of the sequencer, because the sequencer is offline or it's censoring me or is producing an invalid transaction, then if the space and the cost of execution of transactions on layer 1 becomes prohibitively expensive, then I am effectively being denied service. I am being censored, and there's nothing I can do about it, because the value of my transaction is much smaller than the amount I would have to pay to actually initiate this transaction. And there's already something to that regard happening on Bitcoin, where basically the cost of closing a Lightning channel is becoming prohibitively expensive because the demand for Bitcoin, quote unquote, block space, it's a little bit different in their land, is becoming prohibitively expensive. So I think that you cannot basically scale through L2s without also scaling through L1s. And I think that sharding of execution is also important. It might not be as important in a monolithic sense, where you're putting everything on one blockchain and validating everything through one sense of consensus nodes and one set of execution clients. But regardless, you need that block space to be able to bypass the rollups. Otherwise, you just end up with a bunch of sidechains that are actually not sharing security with anything other than posting proofs via data availability, which is only half of the equation. You also need the ability to bypass the actual rollup for it to be a valid L2. And this is a segue into the question, like, what is a valid L2 in your opinion?
Anything that really is is not Ethereum that can write back to it, I guess, is a rough definition in my way. But if you're thinking, to go along with your question, which is about parallel execution or sharding, the idea is that why would you want to do this? So currently we're limited to about 10 TPS on Ethereum, and if we go to different chains, we can get hundreds of TPS. And then if you go to some parallel execution chains, like let's say Solana or Sui, as a new one, or from like the Libra sort of children chains, you can get then tens of thousands of TPS because they're doing the process of parallel execution. This ultimately means that if you have two transactions that have different contexts, then they ultimately can be executed separately without any state dependency between them. So I think currently some of the limitations are that when you're executing across many contracts, the data that you want to change or the state that you want to change is held within those contracts. So in order to do it atomically without double spending is that you need to sequence those transactions going through the EVM. Even though they may not be related at the moment, they currently are. So with parallel execution, you could do this. And there are some techniques that could be used in Ethereum now, namely access lists that you could use, which aren't necessarily used at the moment, or we don't see them being used. But then if you look at other chains and how they work, is that state is stored within the account of the user, not necessarily underneath the contract, which now makes it a little bit easier to basically branch out and run sets of executions on specific user accounts interacting with contracts. So it's easier to grab smaller atomics around that small part of the data, as opposed to having global state, which now has to be sequenced all in order globally at 10 TPS. So, I mean, I don't know if that answers the question or not, but it's some information about parallel execution, I guess. It might be useful. So,
so the original question was, what do you consider as L2, right?
Right.
Well, it can be a state channel or roll-up, and now, of course, we have arguments about whether side chains are L2s or not, whether commit chains are L2s or not. But I fail to see why does it matter so much. Like, why this definition is so important. What's the point? From what angle are we looking at why it's important?
Well, here's the thing. How do I put it? Different things are different. Wow. No, what's important is to understand like what you're dealing with. And I think the different scaling technologies have wildly different properties, and they are being bundled into the same category so that they can appear like the ones that have certain undesirable properties in certain cases can ride on the coattail of those that are quote unquote better or quote unquote more secure, whatever you want to call it. Like personally for me,
in a marketing sense, right?
Yeah, it's like 5G basically. You know, it's just you just use 5G because it's better, even though it's like a wildly different technology and wildly different upgrade than 3G to 4G to 5G. It's like it is a marketing term, but it shouldn't be. Like layer 2 is something that shares security with layer 1. And this sharing of security is something very, very specific. It basically means that what if a layer is a blockchain or anything that orders transactions and executes transactions, then layer 2, in my definition, and something that I ascribe to, is something that you can bypass on layer 1. It's that simple. So if you have a side chain or a commit chain, then it's not a real layer 2, whatever, you know, in this definition, because it exists fully and independently from layer 1. It doesn't need layer 1 other than it's like a nice add-on to have. It's utilizing it a little bit. If you have, let's say, a Validium or something that posts transaction data on Ethereum in this blob space storage, or posts it on a data availability layer, if you cannot use this data to reconstruct the transaction and execute it on layer 1, then this is problematic, because you can still be censored on this layer regardless of how well implemented, how well executed it is. And I think that scaling tech needs to converge to this for it to retain the properties that layer 1 has and scale in, let's say, censorship resistant, neutral and equitable way.
Yeah, in a broad sense, I would just say layer 2, or what I tend to imagine as layer 2, is a layer which offloads some of the work from the layer 1. So it makes, it's just, yeah, it offloads the work. And now these are in the case of modular blockchains, it becomes even more complicated, because, you know, you're gonna, in the future, you're going to be able, I mean, even now through maybe Cosmos Hub, you're able to rent a security from Cosmos Hub, or in the case of Celestia, they work heavily with the Optimism stack. You will be able to rent security from any blockchain you want, which you consider secure. So it's quite interesting. And then you have all these in modular economy. It's getting even more confusing. What represents, you know, which category you're going to put something. Is it going to be an app chain? Is it going to be L2, L3? It's going to get even more complicated, I think. Like before, we were all calling sidechains as L2s, but now it's not anymore. But then in a year or two, it's going to be a complete mess.
Yeah, I think the idea that as a developer with your, you know, to improve your experience, if you're building an application, let's say it's the new trading DEX, and you wanted to build a chain specifically, let's say with no gas, allow your traders to basically execute on tokens that you can bridge across to your app specific chain. You can now choose all of these different, you can understand the different concerns. Maybe you start on Ethereum with the EVM, but then you want to run the EVM on a different consensus layer. So this is like, it really becomes a choice. And obviously to sort of branch out and to scale across, like to scale all of the different use cases that we have, to build a layer 1 now is far easier, and there are far many more choices than just say forking Bitcoin or Ethereum. Whereas Ethereum now is actually, the client implementations are far easier to work with and are far more abstracted, so that you can replace different types of layers, like we're just seeing with the Ethereum upgrade, from proof of work to proof of stake. This was a module that's swapped out. It's fairly easy. There are many different types of consensus mechanism you can add in there as well. So again, it will get more complicated, and it's purely up to, it depends on the trade-offs you want to go down as an engineer, as a developer, and also like, what is the end user experience? Do you want people to make multiple trades and have them sequenced based on the context of what they're trading, as opposed to globally sequencing everything where obviously the slowness kicks in? Because ultimately, when you're making transactions, you're effectively loading all of that information, sequencing that in the same execution environment. So this is obviously where, you know, optimizing the amount of data that gets loaded will improve speed massively, and then also being able to separate that out into many different parallels. And whether that's at the execution layer, at the data storage layer, or like what you actually use as part of your consensus, you know, it all really, it really depends on what you want to do, whether it's, you know, security, scalability, or even if, you know, you have data that is completely ephemeral, you don't need to keep the history of it. You know, there's lots and lots of different use cases and many different solutions for all of these. So.
Yeah, so the way I see it, there is a whole forest of solution to this problem, and it's going to grow even bigger, because there is quite a bit of an incentive to try and produce different solutions and try and experiment in this field. There's a lot of money in scaling, and I think this will continue to be so for quite some time. but then we might see a bit of a convergence, because in the end the use cases allow for certain things, and as an app developer you will converge towards liquidity, because if you're doing financial applications, you want to do stuff that on chains that have liquidity, that supports your application. And if you want to do something that requires scaling on a much larger degree, then you will perhaps use something like a Validium or something like that. But in the end, you will converge towards the chains that have liquidity, and you will converge towards chains that have good bridging. And that is my next question, because one of the things that you sort of lose out when you abandon this monolith is the ability to seamlessly and efficiently communicate between different contracts, to just send a transaction from one contract to another, and it just sort of works. And I think that whichever definition of layer 2 we can accept, the problem becomes that if I want to send basically something cross-chain, I run into a whole plethora of problems that arises from basically ad hoc solutions. So my question for the rest of the panelists is, where do you see how bridges will evolve in this tumultuous space?
Since the mic is with me. Well, I've seen actually two interesting topics in your question. One is related to liquidity, other is related to composability, I guess. I will leave composability to Maxim because I think he's better at that part. And when it comes to liquidity, and I would connect it to the network effect, and I would like to say just a few words about Arbitrum. And how important, from the community view, how important it is to get this network effect, which they managed through the token, airdrop farmers, and but also through perp dexes, because they managed to capture that sector seriously, because there was a huge hole. We had the DYDX, which is a perp dex, which is not composable. And there was a huge problem within DeFi community because we didn't have a perp dex that you can build anything on top of that and create a whole ecosystem. Some maybe, I don't know, asset management vaults or whatever you want to connect to that, or lending applications. So when the Arbitrum came, all perp dexes started using it, and that's where, and they have a very good revenue model. These are profitable platforms, and all the biggest dexes except perp dexes except the OIDX are right now on Arbitrum. So Arbitrum right now has a huge use case, and they also did a very good thing of distributing their tokens to not just to users but also to DAOs. So all these DAOs that represent certain platforms, certain dexes, are distributing their tokens, these tokens, as rewards to the users. We are going to see how much of this liquidity and locked capital is gonna be sticky. How many users are going to be sticky once the rewards dry up? But considering that these projects tend to be quite profitable, I think that Arbitrum has a very nice shot through that sector, but we're going to see, you know. So I think it's going to be, what I wanted to maybe touch upon is a network effect and how difficult it might be for some other projects, L2s, to, you know, take their share of the pie.
Bridget. Yes, so this is an interesting part of the ecosystem, is that when we talk about layer ones and we talk about bridges, ultimately the idea is to move the token from chain A to chain B. Now, what we're seeing with modularization and the way bridges are set up is that you have basically a small validator set that effectively has a multi-sig control over the tokens of that bridge. And obviously we've seen many exploits and hacks and so on around this. Now, what we're also seeing is that bridges are turning into their own execution layers, their own blockchains themselves. So this is now changing the dynamic. This is becoming enabled because of the modularization that ultimately you want to be able to take from, like purely from Ethereum, you want to be able to execute within a smart contract on one chain and have that settle on another chain. And this is now being enabled through summer chains that we see in the ecosystem. We have like Gravity Bridge, we have Axelar, all offering these types of, let's say, modular stacks behind their solution. And this is where we're seeing a lot of movement. There are also projects that are looking at sharing liquidity across different chains, so basically allowing you to basically have access to liquidity immediately across chain. I think this I first saw this concept, I think, with Aave v3's portaling system, where you could basically pool the liquidity across many different chains and move it to where it's needed the most. So if you had an account on Ethereum, you could move it across to Arbitrum quite easily without even having to do the bridging yourself. And I think obviously when you are bridging your tokens, it's very difficult because you need to have gas on the other side of that bridge. And this is like a common problem we have. And obviously there are nice solutions that we can use, like with Li-Fi allows us to basically go across the bridges, route for us, and give us tokens on the other side. These are nice improvements, but ultimately what's happening is that you could have your custody held in Ethereum, and you could execute on, say, Arbitrum on Mycelium or something, and then bring all your profits back, let's say within the same transaction. That's probably the power of where the bridges are moving to, and I think the modularization of blockchains really allows us to go from being a very simple mint and burn bridge from one side 30 minutes later then you might see your tokens if you're lucky, to actually you can build a full consensus execution layer to allow you to move the tokens across to different chains and to execute and to come back, and to be able to do that immediately, to be able to do that more securely. I think that's where a lot of these sort of bridge type chain solutions are going. So
maybe to add, just speaking of this modular approach, one of the advantages that rollups have if they are tethered to Ethereum is that they can use Ethereum to prove to each other that a certain block has been executed with certain state changes. So you can have essentially the same solution that you would have in a monolithic stack, which is basically you have a shard. In this shard, you have a contract, you have an account. Especially today with account abstraction, basically you have a smart contract that gets locked, and then executes, stays frozen with some state, executes a transaction. This transaction is routed to another shard, or in this case to another rollup, and then in this case performs a transaction, hits another contract, and then finishes and returns to the original originator. So you could, in theory, have a very tightly coupled system that uses proofs basically between chains. So you can say, okay, I've initiated a transaction on this rollup. Here's the proof. You have a certain waiting period. Then the transaction resumes. It fires off on a different rollup. Then again, this rollup proves to another rollup that the continuation of this transaction has occurred, and then so on and so forth until the transaction finishes, until you run out of gas. The advantages in this case are that A, you're using the same token for gas, which is you don't have to worry about the end of the bridge problem. You're not having enough tokens to complete the transaction, and you have this one layer that everybody can agree on that proves to every other rollup, every other shard, quote unquote, that the transaction has transpired. So essentially, I think that this is this will go beyond just liquidity, beyond just the concept of tokens. I think the end game is that you have this seamless sort of bridging between rollups through a shared standard. Okay.
It's very cool.
Okay, I have no idea how much time we have, so I think we have 5 more minutes. So questions and closing thoughts, but first questions. No, sir.
Here we go. So, so aren't rollups really just fixing deficiencies in Geth?
Yes.
Yes. Yes, if we had Geth and if Geth was good, then none of this would be a problem. But unfortunately, having Geth be good enough is impossible, so here we go. Anyone else? Don't be shy.
What do you think of Reth?
Next question. I'm not that very intimate with like different execution clients, to be honest.
Yeah, I think the ones that the one I really like is EVM. I think this has been tried and tested and used everywhere. It's probably like the go-to. All of the smart contracts, despite all of the issues you have with, let's say, security or ergonomics of development and building, is that it is actually a proven system. We've seen a lot of copies of the EVM being used in different scenarios. One of them, which I'm paying close attention to, is looking at how CBDCs are reusing this technology. There's a case study released on Mbridge, which was a Chinese international settlement system between countries in Asia, and that was using the EVM, and obviously tried and tested contracts that we use in Ethereum in open source. This is a permission chain between these countries, but it just shows the power of the EVM, and that, you know, if you wanted to trust X amount of billions or trillions that these countries are trading and settling it immediately, then that's like real validation, real proof that it is a solid system. And then you look at the innovations of, let's say, Fuel as one of the other sort of the modular execution layers. This has it's using Rust as its language. So there's some nicer ergonomics than, say, Solidity. Well, depends on what your preferences are. But also it allows this parallel execution to happen as well, so that you can actually execute many more transactions. Could the EVM do this? Could we change Ethereum to copy a similar model? There are hints that yes, it is going that direction. There are some changes in the Solidity language specs that's allowing us to build in these primitives, but it's going to be very slow for Ethereum to catch up. So I think this is the nice thing about modular, is it actually gives applications and developers and businesses the ability to actually prototype and innovate on the ideas they want, instead of waiting for the chain to catch up with them. They can go ahead, go out, explore, do frontiering with new technologies, and then come back to where it actually matters, where actually the TVL is, where the actual where people want to keep their assets, where they feel that they're secure. So that's my opinion.
Yeah, I think it's nice that you mentioned the Fuel as well, because I think these are the projects that need to be constantly checked and followed, like Celestia, Fuel, Cosmos, of course, and based on the lessons learned there, I think Ethereum will kind of try to follow. I mean, network effect with Ethereum is still the largest. So, yeah.
Is that it?
Have you got any questions? Did you enjoy? I hope so.
In any case, yeah, I thanks everyone for your time. I hope you were entertained and maybe learned something new. And we were very, very glad to have the opportunity to talk to you all. And if you want, you can catch us later in the conference, and we'll be very happy to answer your questions. So thanks again. Thank you very much for your time, and that will be all.
Thank you.